Dear students, welcome to the knowledge series. Today we will discuss on rules of inference. This is another important segment of the fuzzy systems, because in this inference there are certain factors that we have discussed in the previous series of the fuzzy propositions. As you might have gone through my proportional logic variable, there I have discussed about this rules of inference, certain factors. Now just may refresh that the point which I discussed there in this particular slide is that we discussed on the inference technique. There are three rules are there for inferring the facts. That is the rules of inference. That is, one is modus ponens, modus tollens, and chain rule. So more about that one, you can go through that particular series, and there I have explained about the facts. Now the same thing but in a tabular form I have put across this one, which you can see, even refer to the books also, you can find the similar things. So here the modus ponens we can represent as if propositions P is true and P implies Q is true, then Q is true. So that is what the rule says about the modus ponens. So this is satisfy the condition of a tautological, because tautological condition talks about the true facts. Similarly, modus tollens is also given if P implies Q and negation of Q is there, then negation of P also exists. So this is also the another way. Hypothetical syllogisms, it talks about that if P implies Q, Q implies R, that implies P implies R. That is a hypothetical syllogisms. Next come disjunctive syllogisms. That is P conjunction Q and negation of P. That implies that since this is a union set, so here Q can be different also. So that means this is true, this is false, then Q is true. This implies. Additions is also shown here. Similarly, the simplification, conjunctions, and resolutions is has been put together. So all these conditions which has been put under the rules of inference, that gives an idea about how from the fuzzy rule based, when the block is being shifted to rules of inference, how the inference is applied to identify that rules can be able to put together to derive the conclusions. So this conclusion is based on these particular inference. So fuzzy inference and the fuzzy rules are different. Fuzzy rule talks about if and then, if then else, all these conditions. But when the fuzzy inference is coming, it looks for the truth value, and based on the truth value it decides that fuzzy set, and that how it goes to the defuzzifications. Now if you still go to the fuzzy reasoning, there are different type of a reasoning of a fuzzy reasoning is there. The one fuzzy reasoning is actually what exactly the fuzzy reasoning is. It's the collection of a fuzzy rules, and based on the fuzzy rules means there is an antecedent is there and a consequent is there. So this antecedent and consequence in the fuzzy rule based, where the antecedent describes the conditions and the consequent it describes the conclusions. So based on this antecedent and consequent in the fuzzy logic, it allows the fuzzy propositions based and the fuzzy propositions reasoning. So that's how, if you know if and then there you apply the fuzzy reasoning. And there are four modes of this fuzzy reasoning, which is called as approximate reasoning. One is a categorical reasoning, another is a qualitative reasoning, and syllogistic reasoning, and dispositional reasoning. Categorical reasoning means in this type of a reasoning, what exactly happens? The antecedents contain no fuzzy quantifiers and fuzzy probabilities. Here we consider the fuzzy variables. Fuzzy variables, that is known as a categorical conditions. So we take a fuzzy variables into account, and there how we try to create the membership functions, and based on the fuzzy logic concept, we try to see that how we can do a maximum minimum compositions, how we can apply the supremum, how we can apply the perpendicular projections. All these things is coming under the categorical reasoning, which we had discussed earlier. So that is known as the class of the categorical reasons. Now coming to the qualitative reason. Qualitative reason, basically it is the input-output relationship of a systems, and that is based on the conditions with respect to the antecedent and consequent. That is the if and then rules. So if then even the else also is coming. So based on that, we can able to give a qualitative reasons. That means it can have some meaningful representation in the case of a qualitative reasoning. Now coming to the third is nothing syllogistic reasoning. Now in the case of a syllogistic reasoning, antecedents with the fuzzy quantifiers are related to the inference rules in this case. We try to take the antecedents, that is the if the initial case, input case, and then the fuzzy quantifiers is being taken in this particular cases, and thereby we try to creates the reasoning based on the inference rules. And what are those inference rules? We have seen in the discussions, modus ponens, tolerant, like that. Different rules are there that is being applied in the syllogistic conditions. And finally, we have a dispositional reasoning, in which in this type of reasoning, the antecedent are dispositions. In this case, antecedents are dispositions that contains the implicit or explicit fuzzy quantifiers in things in this particular disposition reasonings. And here we apply the similarly in the projection conditions. We apply the we take into consideration with respect to the chaining rules, and we take the rules of inference, and we take into considerations the conjunction syllogisms. All this thing is coming under the fuzzy reasonings. So one way you have to understand the fuzzy reasoning is a part of the these rules of inference, and that's how it will able to quantifies the how we can how the systems can able to infer based on the several factors like a fuzzy rules, and based on the fuzzy sets conditions. Now we discussed with respect to that the another rules of the inference. Now in the rules of inference, it can be divided into two types. One is generalized modus tollens and generalized modus ponens, that is GMT and GMP. GMT, it says that if X is A, then Y is B. If that is the case, antecedent, this is a consequent. Then if we take a complement of this one, then this complement is this one. So this is the GMT rule. So this is the true conditions. So that's the statement. If this is true, and if you take a complement of this one, this is false, then this is false. So that means if this is false, that is a true statement. That is what in the GMT. When you talk about when we talk about this particular case in the tolerant, so this is basically we consider as a backward chaining rules under this particular based systems. And when we take a GMP, this is expressed if x is a, then y is equal to b. Then and if you take if y is equal to complement of this one, then x is also complement. That means if you take this part as a false, then this is also false. So that is what. So if this is a input statement, then this is the output statement. So that is what here it indicates. So for a GMP case under this particular segment of a discussions, you try to see this one is that when we take a membership value of my represent in terms of a membership value, then the membership value of this one is represented in terms of a mu b of complement of y is equal to mu a of complement of x into mu r x of y. This is the relations. And GMT here in the case of a GMT representations, we state that mu m of t is represented in terms of mu is a of a complement with respect to is equal to mu b of complement of y dot mu r of xy. So this is how we represent this one, where this one is nothing but the relations between the x and y, and this is nothing but the complement of the fuzzy set B, and this is the complement of fuzzy set A membership. So that is how we represent this GMT rules in the generalized models pollen and tolerant. Now how you deduct the inference? The inference is deducted based on the cases like if you are taking A between A and B, if A then B. So that is what we in the syntax A implies B. First, a rule translates into a relations using a Cartesian product between the set A and B. So if we take a relations between these two sets, that is A cross B union A complement cross Y, where Y is nothing but the universe of discourse. That's how we represent that if A and then B. And in the similar way, if we try to go across the representation in terms of membership functions, membership. So if you represent membership of R is nothing but a maximum of membership of A, maximum of the entire, where the minimum of a membership of A and B is taken, and the complement of membership of A is taken. So on the top and that is how we represent the membership of this particular relations relations of the inference systems. Another way we can reply is that if A implies B, it is defined as a Cartesian product of x cross y, where BC can be, that is a complement of B, can be found with a set of theoretical values. Now if you want to find the complement of B, that is equal to complement of A compositions R. So A complement compositions of entire, that is the A cross B union A complement into Y. So that is how we this relation R is coming here. That is what we represent the B complement. So then this implies a true statement. Now modest Ponen case, if you look for directions under the three case, if A then B else C, then in that case this this Y will be represented by replaced by the C. So that is how we. So here B of C is equal to A of C, A complement into R. So these are the two things is coming in as per the definitions of this statement. So if you write in terms of a membership, then mu R of xy is equal to the entire is represented just like the previous case, membership function of x conjunction of membership function of B of y, its minimum operation, then the negation of membership functions is done, or the complement is done of a membership function of x and its conjunctions with the complement functions with respect to the complement functions is done with respect to the y case. That is how mu c of y. So that is how we represent these particular notations. So this is also going to be true conditions. So that is how we term these three in terms of a tautology. So what is tautology? Tautology has always true value in all conditions. So if these conditions meets the true value, then the particular inference we satisfies. So inference is deriving from the rules, fuzzy rules, which has come, which has been created based on the fuzzy set after the crisp has been crisp input has been converted to fuzzy set by fuzzification. So the rules has been taken, and there we the fuzzy inference is applied to find the true values. Now let's see the two examples which can give a eye opening for you to understand. Now here the two inverse of a discourse is taken, classified as x is equal to a set of element 1, 2, 3, 4, 5, 6. And another fuzzy set is we are taken y is equal to 1, 2, 3, 4. And it is asked that define the crisp set. A crisp set A is taken where 2 and 3. What is 2 and 3? This is nothing but the element, okay, where its membership value is equal to 1 on y, and b is equal to 3 and 4 on x. So that is what is been defined here. That means that this crisp element is on this particular set, and this crisp element is on this particular set. Determine the deducive inference if A then B. Now what is if A and then B? This is the deducive inference. You have to remember that this A and B, if you want to find, if you want to rewrite in terms of a relation, you remember these expressions. R is equal to A cross B union complement of A cross Y. Now that is what we have written here. Okay, this is what we have written in this particular case. Now here how will you solve this one is that first of all you are having a is equal to 2, 3. So here this is equal to 1. What is here on Y? So this is your inverse of a discourse. So this discourse, based on discourse, this fuzzy set A can be represented in terms of membership values and the crisp element. So that is how in here the value 2, 3 is existing. 1 and 4 is missing. So the crisp element of 1 and 4 value is equal to 0, and 2 and 3 is equal to 1. That is what I mean to say. Now when you talk about a B, you try to see the B is 3, 4 for the inverse of discourse X. So here when you try to see this particular problem, you will find that in the B 3 and 4 exist, and whereas the 1, 2, 5 and 6 it is missing. So that is what you try to see in this particular scenario. So when this particular problem if you have to solve, you first rewrite here 0, 1, 0, 2, 3, 1, 3, 4, 1, 4, 0, 5, 0, 6. That is a numerator is a membership value, denominator is a crisp element. So that is a crisp set values. Now taking into consideration the Cartesian product, first we go for A cross B. So we represent how we will represent. We write 1, 2, 3, 4. 1, 2, 3, 4 is the element value. 1, 2, 3, 4, 5, 6 is this value. So we try to take like 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 2, 6. Every time when I say denominator to denominator, at that time we take the numerator the minimum value. That is 1 to 1. So what is numerator? 0, 0. So among this, what is the minimum? 0. Similarly 1 to 2. So what is the value? 0, 0, 0. Like that we do. Similarly we go from 2 to 1 like this one, 3 to 1 for all, 4 to 1, 4 to 2, 4 to 3, like this and see. Like that we find the minimum value. And then we do the counting A cross Y. A cross Y, how will you do? A cross is the complement of this one. So reverse of this one means this become 1, this becomes 0. That is what represent. And Y is what? Y is the, sorry, this is here one correction is that this is when it has been put for a Y in this particular case. So we take into considerations this one, Y is 1, 2, 3, 4. Now here other part will be 0. 1, 2, 3, 4, if you take it, other part is equal to 0. Okay, this part is equal to 1, 2, 3, 4 is equal to, Y is equal to 1, 2, 3, 4. Okay, so this 2 part is 0. Please take into consideration it has put 1. So if it is 0, you try to apply and compute these values. So if you compute this value, correspondingly what will happen? Let me take the first case. 1, 1, 1, 2, 1, 3, 1, 4. If you take combinations up to this point, all are 1, but this will become 0. That 2 value becomes 0. Okay, and when you take a second case, 2 with, because minimum operation, 2 is 0. When you 2 with 0 you do, already it is 0, so that value is also 0, correct. Now third case, 3 with 1, 3 with 2, 3 with 3, 3, 4, all with 0 as a numerator, the minimum value will be 0. And finally this is also 0, this is you consider as 0, so that is becomes 0. And finally 4 case, all will be 0 up to 4, and this 2 becomes 0. So that the changes is there. So here one error as mistake has done for the writing in place of 0 it has 1, put as 1. So these corrections you should notice for the for working out your exercise yourself. Now once we know the A cross Y, A cross B we have knowing, so we take compositions. That is we take a union. So in the union case we take a maximum. So what is, how will you do? We are having A cross B 1, 2, 3, and what is this one element? This element is same as this one. So we ignore this one, so and we directly go with this value. So how will you how will you do? We represent the union operations of this one. So we take this one 1, 0. So what that everything is 1. Like that one, we go with the entire this one. Again we take this row and this row. So here union the same thing. So what you will get this value. So that is what you have seen this one. And here not this value, means you get this, wherever 1 is there, you get in this one all the 1, it will also come. So that is how we represent. We got it this value. Now let us see the third one. Next question. Now here a question with us. So if A, then Y, and else C is given. So C is given this value. Now it is asking for a fuzzy relation R. Now how this R is going to derive? Now this R is based on this C. So you are knowing the A complement. A complement is how much? A complement is given here. Now what is C? C is here. So what you are going to do, you take this A value similarly, and C also you are going to rewrite like this one. You see 2, 4, 5, 6 is 1, 2, 4, 5, 6 is 1, others are 0. So between that denominator to denominator you do a mapping, and the numerator you take the minimum value, then you get these values. And finally you write the R max is equal to A cross B comma A cross C, that is equal to A cross B union of A cross C. So you do the union operation of A cross C and A cross B. Now why you are doing? Because you are doing based on these conditions. If A, then B, and else C. And there that's how you will be coming to the answer of this one. So where this R shows the relations with respect to this particular fuzzy rule inference. So this is how we do the fuzzy rule inference systems, and I believe that the fuzzy rule inference is one important concept where you have to understand that fuzzy rules, fuzzy inference, fuzzy set, and which all are different things and all are contributing to get the truth values after the fuzzy inference. So with this I conclude. Thank you.